All right, so when we see the phrase removable discontinuities, we just think that's the hole in the graph. So in an example like this one, when we factor x plus 11, x minus 11, we already know there's a hole in the graph anytime a factor cancels. Therefore, I would say I have a removable discontinuity at x equals negative 11. The best way to remember what that means, to me, I mean, this was what I was taught in high school. Removable discontinuities are those that you literally remove by canceling. They are removed from the equation. Non-removable discontinuities are like asymptotes. Those do not come out of the equation. In fact, I would be left with this one as 1 over x minus 11, and I would know that means I have a vertical asymptote at x equals 11. Those are non-removable discontinuities. So if like on a multiple choice question or the homework we had last night that you couldn't answer those questions, it says which ones have removable discontinuities. It's just any of the ones that factor in there's a hole. That's it. So it's not real complicated, but like we didn't talk about the word, so you didn't know.
So why wouldn't that be negative?
It would be for the removable one, yes.
Okay,
The vertical asymptote is at 11 because it's the positive one. Whatever you get when you set it equal to 0.
Would you have to like plug it in to find the point, or just?
It could depend on how it was worded. We do know, that if you have x equals negative 11 as a whole, you can plug that into the equation once it's simplified to find the y value. Yes? So like if I know there's a hole at negative 11, I can take this simplified version and say 1 over negative 11 minus 11. What's that going to give me? 1 over negative 22. So the hole officially would be at that ordered pair, which we'll use today as well. We'll practice with that just in case. You might just need to know where the hole is, which is just the location and the x value. Some multiple choice question might ask you to find the whole point. So it's good to know to be able to plug it in.
So that's if you're wanting to find the whole point.
If you need the y value of the hole.
Okay. So are we going to have any questions that ask us about like the non-removable discontinuities?
I'm not sure on that one, if they talk about those. I know when we discussed it before, like I was going over this lesson with her, she just said they will ask about the removable ones. I've not seen any questions that ask about the non-removable ones. But we will spend a lot of time on vertical and horizontal asymptotes, which is what we're doing today. So flip the page. We'll just keep rolling through.
So
Now we're all caught up, and that removable discontinuities, which I really feel like I can't say without saying it wrong. It just comes out wrong when I keep talking. I know. It just sounds funny. Yep, that's it. All right, so today we are focused on infinite limits, okay? And it's basically learning the difference between the limit at infinity or negative infinity versus when a limit's answer is negative infinity or positive infinity. I think I've worded that the correct way. Okay, and the difference is vertical or horizontal asymptotes. So this is really just a review of what we were just talking about. So how do you find vertical asymptotes of a function? We set the bottom equal to 0. How do you find any holes? We just kind of talked about that. Okay, factors that do what? Okay. So the vertical asymptotes happen after you cancel the hole, right? You all know that? You got to factor, cancel the holes first. Then you can find the vertical asymptotes by setting the bottom equal to 0. Okay? So our definition in calculus of vertical asymptotes is any place where the limit as we approach, and I'm going to put a little plus sign here, but it could be a minus sign too. Okay, we can do plus/minus. Plus, I think I just said that right, is equal to infinity or negative infinity. Okay, so what this means in English is basically any time I'm finding a limit from the left and the right and it goes to infinity or negative infinity, it's always a vertical asymptote, right? We can make that correlation. Nowhere else are you going to get a limit that equals positive or negative infinity. It's only at asymptotes. Now, horizontal asymptotes are completely different. So think about like when we did these in class last year. What did we use to figure out the horizontal ones? Bobobot needs DC. Napier loves that one. She thinks it's stupid. I think it helps you remember it. Okay, if you don't remember that, that's our mnemonic device that says if my exponents are bigger on bottom, y is equal to...
Now, what is she like?
She is not a fan of all things cutesy, and she thinks that's cutesy. The textbook says if the highest exponent on top is p and the highest exponent on bottom is q, if p is bigger than q, then this. If p is equal to q, then this. Yeah, I know, exactly. This is easy to remember. Therefore, I use it. So this one says if the exponents are bigger on bottom, then y is equal to what? 0. If the exponents are bigger on top, then there is none. And if the exponents are the same, you divide your coefficients. I forced her to use it last year because I taught this and she had to use it. That was all they remembered. So she did hate it. She thinks it's all cutesy. But when we talk horizontal asymptotes, think about a rational function. I'll just draw one real quick. Any rational function. So let's say we had a rational function that looked like this. I just draw one. What do the horizontal asymptotes tell us about the graph? Or what parts of the graph does it describe? The y as we head out to both ends, right? So what it really talks about on these kind of graphs is the end behavior of the graph. Okay? How do you find them? We just wrote that up here, so don't feel like you have to rewrite that again. So for horizontal asymptotes, what they are going to be defined as in calculus is the limit of our function as x approaches positive or negative infinity. Because isn't the end behavior as x heads out to negative infinity? What's the graph doing? As x heads out to positive infinity, what's the graph doing? Right? So that's the difference, and that's why we talk about them together. Vertical asymptotes are where your limit from the left or the right is equal to infinity or negative infinity. Horizontal asymptotes are the answer to the limit at infinity or negative infinity. So they kind of flip-flop where the infinities are, right? One's here, one's here. Yeah?
So, just looking at the problems that we did, if there's a vertical asymptote and say it's like that, the limit can't exist.
Ever.
But if there could be a horizontal asymptote and the limit could exist?
Yes, the limit will exist. It will be the number that the horizontal asymptote is at. Okay? Yep. So if you have a vertical asymptote, the limit is always going to be at that number, does not exist. From the left or from the right, you can say it's going to infinity or negative infinity. However, if you are having a horizontal asymptote, that is going to tell you what the limit is at infinity or negative infinity. And that's going to be the answer. Okay? The only way to do that and figure that out, because this feels a little, I think I'm following you, but I'm not exactly following you. When we do a problem, trust me, you'll follow it. Okay? So we good to try one of these?
Yes.
All right. So this is a very straightforward rational function. Okay? So thinking about this, and I'm not going to graph all of these. Okay? But just for now, so we have a visual, we're going to sketch. We know what the parent function of the rational function looks like, right? Branch, branch. This one has a vertical asymptote where? X equals 1. Okay? All right, so later, you will not have to actually draw a picture of this because you will have a full understanding of if they're asking about the limit at the vertical asymptote, it's going to be from the left and the right, it's going to be an infinity or negative infinity, or if it's at 1, it's going to be does not exist. And you're going to be able to say that without actually graphing. And if they're asking about the limit at infinity or negative infinity, they're just asking me to say what's the horizontal asymptote. But for the moment, let's just take a look at the graph, okay? This one has a vertical asymptote at 1. Where would it have a horizontal asymptote? At 0, because this is the case where it's bigger on bottom. Because there's no x on top, right? Highest degree is 0. So right now I have my 2 asymptotes that I've drawn in. And because there's no negatives on my function, where am I going to assume my branches are? Bottom, okay, yeah, bottom left, top right. We all okay with our sketch? All right, so based off of that fact, if I'm just thinking about this graph, when they ask me the limit as x approaches 1 from the right, I'm just looking at this and saying, as I come into 1 from the right, where's it headed off to? Infinity. And the limit as we approach 1 from the left, I'm going to kind of track in towards 1 from the left. Where's that going? Negative infinity. The question is not here, but the answer to the limit at 1 would be automatically what? Does not exist. Because this is all about a vertical asymptote. Those are the only answers you can have for a vertical asymptote. Both sides could be going to positive infinity. The limit still wouldn't exist every time. On the flip side, notice this is asking me about the limits at infinity. Not at the vertical asymptote, but at infinity. This is asking me what is happening on the right side of the graph. What is the end behavior on the right side of the graph? This is asking me what's the end behavior on the left side of the graph. Yes, ma'am.
So this one
Mm-hmm.
would be does not exist because of the vertical asymptote.
Yes.
Okay, 'cause it
Your
doesn't
limit
come
is
in anymore.
never going to exist at a vertical asymptote. Ever. It doesn't matter if both sides go to infinity, both sides go to negative infinity, never going to exist. When you're asked the limit at infinity, this is asking me to track the end behavior. And rather than having to guess what is this evening out at, I know what it's evening out at. I know it's going to level out towards the horizontal asymptote every time. So my answer to the limit at infinity is 0. Because as we track out this way, this branch is just going to get closer and closer and closer to 0. Is it ever going to touch 0? No, but a limit is a prediction. What is it getting closer to? 0. On the left side, if I track this piece, I also know it's getting closer and closer and closer to what number? 0. So in the future, rather than having to sketch the whole thing, we're going to be able to say, oh, this is asking me about the limit at a vertical asymptote. Mental picture of it to get the infinities and negative infinities, but I know it's going to be infinity. And I know the limit's going to not exist. Oh, this is asking me about the end behavior. That answer is always the horizontal asymptote every time. Every time. Okay? So are we ready to try a second one of that?
Yes.
All we're doing now at this point is 3 of those to repeat the process and make sure you've got which part is which in your head. That's it. And we're done. Good?
Are we gonna finish early?
We probably will. Maybe you'll have some extra time to work on your prerequisites review and we can chat about that if we need to. Okay? All right. The third example will take us a little bit more time just because of what it is. But we really only have like 4 of them and we're done. Okay? All right, so what do I do first in example 2? Factor. Okay, we need to factor, see if we have any holes, all that good stuff. So I've got x minus 2, x plus 1. My bottom is going to be 2x and x. For my factors to add up to negative 1 in the middle, what has to go where?
It's 2x plus 3 and then x minus 2.
Plus 3 and minus 2, because that gives me negative 4 and positive 3.
Yes, so then the x minus 2 cancels.
So when my x minus 2 cancels, I immediately know what?
That's a whole.
That's a hole at x equals 2. Okay. Let's practice finding the y value. How do you find the y value of the hole?
Plug in 2 to the simplified version.
Plug in 2 to the simplified version. So that means I would do 2 plus 1 is 3. 2 plus 3 is 5. That's my y value.
Wait, I thought you would have to multiply the 2 by the 2 to get 4 plus.
Oh, you do. Thank you.
It's okay.
If you saw how I have it zoomed in right here, you would see I cut off my 2. So I was plugging in 2, 3 on top, and on bottom, I have 7. So that's my hole in the graph.
So you want us to write it as an ordered pair?
Let's just practice doing it, because if we don't practice doing it, you will not remember how to find those when you might need it.
Okay.
For now, we're going to do the little extra. Later, maybe we'll switch back and forth. Vertical asymptote, therefore, at what? -3/2. Okay, we get that from setting the other factor equal to 0. I'm going to mentally just skip this limit stuff right here, right now, only because we're finding all the things about the graph. So let's just talk horizontal asymptotes while we're at it. Okay? How do you find the horizontal asymptote on this one? Bobo button needs DC. What's my horizontal asymptote? 1/2. Are we all okay with that? I look at the original for that. I find the original easier to look at for the horizontal asymptote. Because for me, that's very easy to see. I've got the same exponent here. It's the 1/2. That's just personal preference.
And you always look at the original.
I do. It just, to me, it's mentally a little bit easier than the factored version. You get the same answer either way, but I don't know. It just works better in my brain. Okay? Now, let's talk about all the limits. Because now we need to identify, and I don't want to sketch. Don't want to sketch. Okay? So let's just see if we can do it without sketching. This is asking me the limit as we approach 2 from the right. What is 2 in this? It's the hole. Think about when we graph things with a hole. Okay, what is the answer to the limit at the hole always? The y value of the hole. Every time. A hole always has a limit, right? Because we can always make a prediction. Every time there's been a hole in the graph, we said, well, the answer to the limit is what would the y value be, right? And we've already found the y value of the hole. So if it's asking you about the limit at the hole, the answer is the y value of the hole. Every time. Which is why we do that. Don't even have to look at a graph. Don't have to look from the left and the right. It's the hole, therefore we have a limit and we know what number it is. What about the next limit? This is asking about the limit at what? The vertical asymptote, which is automatically what? Does not exist. If it was from the left or the right, you might have to think about, do I have a reflection? No on this one, therefore you could say where it's going. But if they just straight up ask you about the vertical asymptote, not from the left or not from the right, always does not exist. Yes?
So I can say like every time, no matter what the situation is, if it has a hole, the limit is always going to be the y value.
Yes. Yep. It's not. It's just talking through it so that you get in your head, what am I looking at? Here is the rule for the hole. Here is the rule for the vertical asymptote. Here is the rule for the infinities. Same thing here. Every time they ask about the limits at infinity and negative infinity, they're asking about the end behavior. And every time the end behavior is described by what? The horizontal asymptote. So as soon as you see the limit at infinity and negative infinity, the answer is the horizontal asymptote. 1/2. This limit is 1/2. This limit is 1/2. I don't have to check what it's evening out at on a graph. It's the horizontal asymptote every time. Okay? Does this help with this process? Okay. Now, let me just check. I either want to do 3 first and then 4. No, I want to do 4 and come back to 3. Okay. And then I mentally have to check if I have to do intermediate value theorem, but I don't think I do. my brain. All right, so, bless you. In example 4, how do we start off on any of these problems? Factors. See what cancels. So I've got x cubed on top. What factor's on the bottom? Take out an x. We are left with what? X minus 2. Yeah? What happens with one of my x's? Cancels. Okay, so 1x cancels, which gives me x squared there. That immediately means I have what? A hole at x equals 0. Let's go ahead and find out what that y value is while we're finding information. How do I find what the y value is? Plug it into the simplified version. So 0 squared on top over 0 minus 2 on bottom immediately gives me a y value of what? 0. All right, so we've got the hole in the graph. Come back to vertical asymptotes. Yeah. No, you're fine.
Why is it 0?
Because when we plug in 0 to this, I get 0 squared over negative 2, which is just 0. Remember, 0 on top is fine. 0 on bottom is not okay.
And you always want to plug into simplified.
Yes, because if you plug it into the original, you're going to get 0 over 0 every time. That's why it's a
That's
hole.
what I'm trying to find.
Right. Yep. So vertical asymptotes is where the bottom equals 0. Therefore, we have a vertical asymptote at x equals 2. Horizontal asymptote is what? None. Okay. Now, we talked about horizontal asymptotes that are none last year, and that meant that we always had a slant asymptote. I'm not going to make you find them. It just means that we might have to see what's going on the graph to answer the infinity and negative infinity. Because remember, the limits at infinity and negative infinity are always equal to the horizontal asymptote. Well, I don't have one now. So we're going to have to see what that means. Okay? And that's really the only limits we're finding here. We know how to find the limits at the vertical asymptote or at the hole at this point. So what it means when we have no horizontal asymptote is that we have a slant asymptote. So if I was to sketch this, I do know I have a vertical asymptote there. I know I have a hole in the graph at 0, 0. Okay, I could do synthetic division to find that. It's lovely, isn't it? But in general, it tends to go this way. And you have a branch that looks like this. And a branch that looks like this.
So what do we do with like the reason or process?
And we don't know. We plug in random numbers till you figure out where the branches are, honestly. Or synthetic division, if you remember it, you put the 2 outside. It's just an x squared, 0x, and 0 for the constant, right? So synthetic division would tell me,
Wait, sorry, where are you getting the 1, 0, 0?
so if I'm dividing this into that,
Okay.
you put the 2 outside, you put the 1 from the x squared, the 0 from the x, and the 0 from the constant term, and you synthetically divide it in. Remember this one, the remainder never mattered, and this was the equation of our slant asymptote. It was the line x plus 2. Okay, if you remember synthetic division, this was like the remainder, constant, and x.
What's the 24 from? I kind of got lost.
Where it's not a 24. It's synthetic division where I'm doing like bring down the 2. So synthetic division, if you need to remember that, you bring down the 1, you multiply it by the 2, you put the 2 up under here, you add, you get 2, you multiply and get 4, and add down and get 4. This is your remainder, which does not matter for synthetic on this. This is your constant, and this is your x. So that does tell me that my slant asymptote is y equals x plus 2, which I have pretty decent there. And because you knew there was a hole here, you would know one of the branches is in here, which means the other one is always diagonal from it. So that would be the extent of how much I would do. I wouldn't have to plug in any random numbers. I probably would always prefer to find the slant asymptote because it generally gives me enough information to know where the branches are if you have a hole or something. So officially, this is x squared plus 0x plus 0 when you're doing division. So the 1 is from the number in front of the x squared. The 0 is the x that's missing. The 0 is the constant term.
Okay, sorry.
You remember that? I know, it's been a minute. Yeah. And that one, I'm a little bit at this point unclear as to whether you would have that for like a calculator or not, and that's something like I'll check with her. I'd rather teach you at this moment to do it without, because then we're more prepped. Like we can do it, it's just whether we have to or not. So that means if I'm asked the limit at infinity, I just need to trace out which piece is headed to infinity. So which part of this graph is the one headed out to x equals infinity? The top, right? And in fact, it is, it's this piece right here, right? That I'd be tracing that out. Where is that going to? Infinity. So when your horizontal asymptote is none, your answers to these are going to be infinity or negative infinity, or you could put DNE. But typically we like to be specific about it. It would be too easy to say immediately that's none, therefore this is DNE, this is DNE. We want specific information. Is it going to infinity? Is it going to negative infinity? It's always better to be specific. So as x goes to negative infinity, which section am I tracing? This one, out this direction. Okay, so that is going to be negative infinity. Okay, so that's only for the case of no horizontal asymptote. Now, coming back to the middle one. Are you ready for the middle one? The middle one's super fun. Looks a little bit different than any of the ones we've done before because why? Yeah, there's an h of x. We're in AP Calc AB and we're being extra. There's a square root in the bottom. Isn't that exciting, guys? All right, when it looks weird like this, we can still factor. Factoring is still the answer to 90% of our questions here, okay? What can I factor here still?
Wait, on like the first
Mhm.
just like put down factor.
No, probably not. Yeah.
I feel like every AP is like something, if you put down something, then
Mm.
something.
Yeah, there's some interesting testing strategies that you like go through with this as you go. One interesting thing for AP Calc, since we have time today, is I remember this from like high school. There's a lot of like parts A through like E, probably physics is the same way, on questions. And our teacher taught us, and it's not like the goal to do this, but our teacher taught us, like, let's say you can't get part A, because then you're like, what, you're screwed for the rest of it? No. You make up an answer.
Okay, but that's what we're doing.
And they say, okay, I'm just going to go with x equals this number. I don't know how, like, I would literally, I don't think I had to do it, but she like taught us to do it and was like, you write a note and say, I don't know how to solve this part. Therefore, I'm saying x is equal to 5. And we're going to move on with that answer. And you do the parts that you could, for the other pieces.
Wow.
You lose your points for part A, but if you can solve parts B through whatever using your made up number, you get credit for it. It's like super odd, but
Would we get credit on the test?
yes, because I grade AP style.
Okay.
So you would. Yeah, we'll talk about that. But now let's take a look at example 3 because it's super weird, but also kind of fun. Don't be scared. What factors?
The bottom, so it's 2x minus 1, 2x minus
Yep, 2x minus 1, 2x minus 3. Now, quick question. You know how we find vertical asymptotes by setting the bottom part equal to 0? Okay. These factors are still multiplied by each other underneath the square root. So if one of those factors is equal to 0, wouldn't it still make the whole bottom 0? Even though there's a square root thrown into this? Yeah, it would. Now, so I can still set those factors equal to 0 to find a vertical asymptote with one additional piece of information. Okay? If you set those equal to 0, the way we've been used to doing it, the horizontal one is the one that changes, I think. Sorry, I'm mentally thinking through this one. If I set the bottom equal to 0, I still get x is 1/2 and x is 3/2. So vertical asymptotes don't really change because you can still set those factors equal to 0. If that factor, 2x minus 1, is equal to 0, the whole thing goes to 0. So the vertical asymptote is still the same. Were there any holes in the graph here? No, because no factors cancel, right? Now, here is the super different, not different, but kind of cool part about horizontal asymptotes, okay? Horizontal asymptotes are typically Bobo-Bot and HDC, right? With your whole exponents. What throws a wrench into this one? It's the square root, right? So here's how you have to think on this one. There's an x squared on bottom and an x to the first on top. However, you're square rooting an x squared on the bottom. So technically, what's the degree of the bottom?
1.
It's still 1, okay? That doesn't mean that you're immediately going to say it's 1/4. You, however, are going to still divide your coefficients, and your coefficients are 1 and the square root of 4. And what is the square root of 4? What do we never forget to put in front of square roots? Plus or minus. Okay? So my horizontal asymptotes, I have 2 of them.
So it'd be negative 1/2 or
1/2 and negative 1/2.
For the vertical
Mhm.
asymptote, why didn't you, like you set the parentheses equal to 0, but it's under a square root, so why would it not be?
Because of this. Let's just say we're talking 2x minus 1. If I set that equal to 0, I get 1/2, right? So let's just say I plug in 1/2. 1/2 plugged in for x there is going to give me 2 times 1/2 is 1 minus 1 gives me 0. Well, 0 times everything else is 0. Square root of 0 is just 0. So you don't have to square root the x on that one.
I understand.
Okay? Yes, sir.
I thought you only had to do the plus or minus if you introduce the square root into the problem.
Flip that. If you introduce, well, no, okay, yes, but not in this case. This case, you have 2 horizontal asymptotes every time. It's great. So the good news is you're not actually going to have to sketch this. You have to remember, okay, vertical asymptotes are normal. We treat those normally. Notice on this one, I only asked about the limits at infinity and negative infinity because it's weird horizontal asymptotes, right? When there's 2 of them, how do you know which it goes to? Here's the answer. If you are going to positive infinity, okay, it's not that it's always the positive horizontal asymptote. Right now, I don't have any negatives in front of anything in this problem, right? So because there's no negatives, plugging in a really big positive number to this for your x's would give you out a positive number. So the limit at positive infinity is positive 1/2. If I was plugging in really big negative numbers for my x's, I would get out the negative answer. So the limit at negative infinity is negative 1/2. Now, just to throw this in here because this example doesn't explain everything, if there was a negative there in front of that x, it flips it. So the positive becomes the negative and the negative becomes the positive. Because of that translation, it's a reflection. So it throws it off, right? So it's not always that positive infinity is the positive answer. If like the coefficients of the front would be positive, then positive infinity is the positive answer and negative infinity is the negative. If there is a negative in there like that to do a reflection, you flip them. Does that make sense? Okay, it's a little bit weird. Doesn't come up a whole lot, but it's worth talking about. Okay? Now,